Imagine waking up to find out everything around you, the sky, the city, even you, isn't what you think it is. It sounds like the Matrix, but some scientists now say it could be real. Have you ever considered that our reality might be an intricately crafted computer simulation? It may sound like sci-fi, but research is underway to test the so-called simulation hypothesis. Surprisingly, even researchers connected with NASA are probing this idea. In labs and supercomputers, they are asking, could there be glitches or hidden codes in nature that prove we live in a virtual universe? A deep field theory production, where science meets the infinite. The notion that our universe is a vast simulation has deep roots. From Plato's cave to the Matrix, philosophers and storytellers have long asked if reality is an illusion. The modern simulation debate really took off with Oxford philosopher Nick Bostrom. In 2003, he argued that future civilizations might run countless ancestor simulations of their history. His startling conclusion? If so, most minds in existence will be inside layers of simulations, meaning that we probably are too. In other words, if advanced civilizations create digital worlds, simulated people could far outnumber real ones. The simulation hypothesis says it's more likely we're among the simulated minds. So, is there any real evidence beyond thought experiments? Some researchers think there might be clues hidden in physics itself. If our universe is a kind of cosmic video game, they ask, could we detect the code? Recent stories suggest that scientists, including a former NASA physicist, are designing experiments to find out. Could there be patterns or glitches, just like in a computer game, waiting to be discovered? The idea is catching on. As one report notes, scientists are now rigorously exploring this idea, taking the simulation hypothesis from philosophy into the lab. One of the wildest approaches comes from Dr. Thomas Campbell, a former NASA physicist. Campbell believes we can test if the universe is a simulation by tweaking famous quantum experiments. In 2017, he co-authored a paper, International Journal of Quantum Foundations, outlining clever tests. For example, the classic double-slit experiment shows particles acting like waves or particles depending on observation. Campbell's twist? Delay or hide the measurement so no one knows which path the particle took. If unobserved particles leave no trace until they're measured, it could be like a video game only rendering graphics on demand. He even phrases it starkly. In essence, what you do not see does not exist, meaning unobserved events have no outcome. Campbell and a team at Cal Poly Pomona are building these tests today. They plan to record all data on USB drives and only inspect it later. In a shocking strategy, they might randomly destroy the which path data on some drives, leaving the screen images intact. The idea, if reality is a simulation, erasing the data before observation could erase the effect, like undoing a scene in a movie. As one paper explains, to save itself computing work, the system only calculates reality when information becomes available for observation by a player. In plain terms, we'd look for proof that nature renders outcomes only when observed, just like a game engine. If these experiments find that particles only leave footprints upon observation, it would be an extraordinary hint that our universe behaves like a computer program. Besides double slits, other quantum tests are in play. Some schemes use quantum erasers or entangled photons to pinpoint when reality becomes fixed. The overall goal is to catch a discontinuity or glitch in physics. Campbell even established a non-profit, CUSAC, to fund this work, claiming the experiments are expected to provide strong scientific evidence that we live in a computer-simulated virtual reality. In other words, he's betting on clues hiding in the strange rules of quantum mechanics, rules that famously link observation to reality. Beyond lab tinkering, theorists are hunting for simulation signatures in the cosmos itself. What if the universe has a hidden source code? One intriguing idea comes from Dr. Michael Vopson at the University of Portsmouth. He proposes a second law of infodynamics governing information in nature. According to Vopson, systems always try to minimize information entropy, basically compress data efficiently. In biology, this means genetic information is not random, but optimized. In cosmology, it means the universe prefers symmetry over chaos. He likens this cosmic optimization to a data compression algorithm running behind reality. For example, the universe's tendency to round out asymmetries could be seen as nature's source code at work. While fascinating, this is speculative. Vopson himself admits more research is needed. In fact, many scientists remain skeptical, warning that the simulation idea flirts with pseudoscience or even techno-religion. Still, it's a thought-provoking clue. If there is a rule like Vopson's, it might hint that reality operates by hidden informational principles, a bit like a program's compression routine. Some people also look for glitches in cosmic data. For instance, astrophysicists have asked whether ultra-high energy cosmic rays or black hole emissions show signs of a lattice or cutoff expected from a simulated grid. So far, no smoking gun has appeared. But the search has sharpened. Scientists now know exactly what to look for. Anything that can't be explained by known physics could be a candidate glitch. Here are some key clues scientists are exploring. Quantum experiments. Testing if particles exist only when observed, like a video game, using setups like the double slit. If outcomes vanish without an observer, it could signal a simulation playing out only on demand. Information patterns. Probing the universe for mathematical regularities. For example, Dr. Vopson's work suggests nature's drive towards symmetry, and minimal entropy might act like a hidden data compression, hinting at underlying code. Scientists also look for limits, like an ultimate pixel size or frame rate in space-time, that a simulated reality might impose. Each approach tries to wring evidence from the very fabric of physics. If anything doesn't add up, it might be more than an unsolved mystery. It could be a clue that reality is programmed. Not everyone buys the simulation hypothesis, however. Many physicists caution that these experiments might just confirm what we already know about quantum mechanics, not prove we're in a video game. In fact, rigorous studies suggest simulating our universe might be impossible. A 2025 research paper in Frontiers in Physics calculated the energy needed to simulate even a tiny fraction of our cosmos. The result: it would require astronomically more power than is physically possible, making the idea basically unfeasible. As the authors conclude, with known physics, it is simply impossible to simulate a universe like ours. In short, the math suggests we're stuck in reality, not a virtual copy. Prominent scientists express doubt too. Harvard astrophysicist Avi Loeb, for example, emphasizes real consequences and responsibility. He argues that treating the world as a simulation can be disempowering. As he warns, the notion takes away the sense of responsibility for the consequences of our actions, encouraging escapist thinking. For Loeb, physics should focus on real mysteries, dark matter, black holes, the Big Bang, rather than debates about virtual reality. Still, Loeb hasn't dismissed the idea outright. He's even drafted an experimental test. He proposes using ultra-precise atomic clocks to see if time comes in discrete frames, around 10 to the power of 43 ticks per second, the Planck frequency. If we live in a simulation with a finite frame rate, we might detect tiny jumps in time. Loeb admits his gut feeling is that no such discreteness will be found, but he is open to following the evidence. Other critics simply call the simulation theory pseudoscience or a modern fantasy. They note that every apparent anomaly so far has found a mundane explanation. For example, quirks in particle physics are usually resolved by better quantum models, not by revealing that we're in a cosmic game. In fact, many argue, if reality really is a simulation, the supreme programmers would probably make it indistinguishable from the real thing, pulling the plug on any easy Easter eggs. So what's the bottom line? Are we the unwitting players in a computer game, or is this all imagination? The truth is, we don't know yet. No experiment has produced definitive proof of a simulation. But as scientists admit, searching for such proof is itself advancing physics. Even skeptical researchers have developed new techniques and deeper insights into quantum mysteries and information theory through this debate. It's a reminder that questioning reality, even in outrageous ways, can drive discovery. We've seen that credible experiments are on the horizon. We've heard inspiring claims, strong evidence of a simulated reality, and hard-nosed rebuttals simulating this universe is physically impossible. This dialogue is exactly how science works. Hypotheses are tested, critiqued, refined. Whether we find a secret source code or not, the journey is pushing the boundaries of what we know. Now you have a front row seat to this cosmic mystery. If this video sparked your curiosity, hit like and subscribe for more deep dives into space, physics, and the nature of reality. And tell us in the comments, do you think the universe is a giant simulation, or are we venturing too far down the rabbit hole? Are there clues we missed, or experiments you'd love to see? Let us know. After all, this discussion is open to everyone. Until next time, keep looking up and asking questions. In this grand experiment called life, maybe that will be our true breakthrough. Like and subscribe, and stay curious.